In the grand tapestry of the cosmos, there exists a breathtaking elegance, a symphony of order and harmony that leaves us in awe of its perfection. From the graceful dance of celestial bodies to the complex structures of our body, the universe unfolds with a precision that defies explanation. In contemplating the profound beauty and complexity of the cosmos, we are confronted with a fundamental question. How is it that our universe seems so perfectly suited to the emergence of life? This thought has captivated the minds of philosophers and scientists for centuries, leading to a deep exploration of the underlying principles that govern our reality. Hence, raises many questions. One of such questions is, what if reality isn't what it seems? Nick Bostrom, through rigorous philosophical inquiry and logical deduction, proposed that our existence might be a simulation created by advanced beings. He outlined the argument that if technological progress continues, the probability of us living in a simulation is significant. This idea has sparked widespread debate, challenging our understanding of reality and inviting us to question the nature of existence itself. There were many such theories that came into debate. Another one was around a single constant number. In the world of theoretical physics, Richard Feynman was obsessed with this puzzling number. In mid-1900, despite his Nobel Prize-worthy discoveries on how electrons and light interact, this number daunted him. It wasn't just any number. It was the fine structure constant. Nobody knows it's one of the greatest mysteries of physics. In quantum electrodynamics, it is a number that tells us about the strength of electromagnetism and has a value close to 1 divided by 137. Feynman's theory cannot calculate this number, and his equations are impotent until you measure its value in an experiment. And scientists today are still asking the same question that Feynman asked years ago. Where does this number come from? This quest for understanding goes beyond equations. It delves into the deeper question of why constants like this exist and what they mean for our existence. Imagine these constants as the building blocks of reality, shaping everything from the smallest particles to the vast areas of space. They seem to hold secrets about the very fabric of our universe. It's a philosophical journey that invites us all to wonder, how do these constants, seemingly simple yet profoundly influential, contribute to the grand story? How are we so perfectly placed in the middle of nowhere, yet everything is just so accurately functioning to sustain a healthy life on our planet? In an even bigger question, how did we get here? You're watching Space 9, unveiling the mysteries of the cosmos, your gateway to the universe. Our home is one prime example of just how perfectly our universe is designed, and there are a lot of examples on our little blue planet to support this theory. One such perfection is our planet's interaction with its host star, the Sun. The Sun has a diameter of about 1.4 million kilometers. That's big enough to fit around 1.3 million Earths into it. It has a surface temperature of about 10,000 degrees Fahrenheit, which is enough to turn every living thing on Earth to ash. But somehow, Earth is located at just the right distance to receive enough heat during the day to keep us warm, and still warm enough to keep the whole planet from freezing at nighttime. Just so accurate. Anywhere else in the solar system, and it would either be too hot that water would evaporate from being too close to the sun, or the entire planet would freeze from being too far from the sun's surface. Earth is so perfectly distant from the sun that its location allows liquid to form on the surface, allowing life to thrive and diversify. A planet like Mercury, on the other hand, has a surface temperature of 375 degrees Celsius during the day and switches to below -200 degrees at night, making the planet completely unsuitable for sustaining life. Earth's atmosphere is yet another randomly perfect design set up by the universe. Our atmosphere contains just the right mix of air contents and atmospheric pressure, perfect for most living creatures on the planet. Gases like carbon dioxide can be found on other planets like Venus, Mars, Jupiter, and even exoplanets outside our solar system. But for some reason, Earth has just the right amount to regulate surface temperatures so the planet doesn't overheat. Isn't it amazing? Venus, on the other hand, has an unusually thick sulfuric atmosphere with over 95% carbon dioxide that makes its surface so hot it can melt lead. Mars's atmosphere also has over 90% carbon dioxide on its surface, but the air is so thin and cold that no living organism can survive long enough to utilize it. Surface temperatures on Mars can also reach -140 degrees Celsius, cold enough to freeze blood and any water that may be present on the planet's surface. Another example of a perfect design is that our planet also has an ozone layer. This layer of the atmosphere filters harmful solar radiation from the sun, such that only about 1% of this radiation reaches Earth's surface. Without the ozone layer, we would be exposed to these harmful ultraviolet rays from the sun, which come with a range of dangers, not just to humans, but to the planet's temperature as well. Scientists are puzzled with this thought. Why only Earth? Why is it that only one planet has an accurate environment for life? Has the entire solar system been built just for Earth? If you think about the design of the solar system, it's actually quite breathtaking, considering all the layers of protection we have, and not just Earth, but the other planets as well. And you may be thinking that all these layers of protection are for Earth, since our planet is the only one in the solar system that supports life. Well, it is, and it isn't. The history of complex life on Earth is only about 1 billion years old, and for most of that time, there have been major extinction-level events, leaving our planet void of life for the most part. So who knows? Life might spring up on the desolate deserts of Mars, or in the methane rivers on the moon Titan billions of years from now. So there is a long-standing argument in the science community that the universe could not have simply caused its own existence, nor can it explain its own origins. This argument has gained traction in the scientific community and is known as the fine-tuning argument. The basic tenet of this argument is that in order for anything to exist at all, certain conditions must be met, and in the case of the universe, most of the conditions needed for its creation are extremely improbable. The improbability of a self-forming universe is so large that we cannot simply attribute its creation to chance. In essence, it's only reasonable to attribute these conditions to some sort of creator or unfathomable design. You may be on the side of conventional science that believes the origins of the universe simply began from the Big Bang, and anything before that needs no further explanation. But the fine-tuning argument lays out some examples of a perfectly designed universe that suggest otherwise. The laws of physics that govern the universe have been proven to be true and enable us to understand the workings of the universe. But if you look at these laws, such as the gravitational constant, the mass of the electrons, the strong nuclear force, and many other constants used to describe natural phenomena in the universe, the values of these constants are such that if any were the slightest bit stronger or weaker, the universe would be in chaos and cease to exist. For example, if the gravity of the sun was slightly more powerful, then all the planets would be pulled into its fiery furnace and destroyed. In the same way, if the sun's gravity was a little less powerful, it would not be able to hold the planets in place, and they would go flying off into the galaxy. In essence, the laws of physics and nature itself are fine-tuned for life to thrive and for the universe to exist the way it is. Maybe, just maybe, this is the constant number that daunted Richard Feynman. Discussing how perfect the universe is one thing, but some have gone further to question reality itself. What is reality? And does simply being able to see, touch, and observe something make it real? Well, some scientists have put forth some outside-the-box ideas and theories to explain the seemingly perfect yet complex universe. One of the most prevalent answers can be found in Nick Bostrom's simulation theory. This theory states that the entire human experience may be simply just an extremely powerful computer program. It says we're all part of a computer simulation controlled by an entity whose existence is beyond our comprehension and reach. In this theory, humans aren't real in the physical sense, but are instead digitally coded constructs playing out in a predetermined digital world, much like a computer program. Living in a simulation like this is similar to settings from the hit video game The Sims, except humans are the characters in our very own cosmic level simulation. One major question that plagues the simulation theory is, if we truly live in a computer simulation, then who is the programmer? Bostrom stated in his 2003 paper that our simulated reality might actually be controlled by an advanced race of humans. According to him, these future generations might have advanced mega-computers that can run highly complex simulations, programs so advanced they are beyond our current comprehensive abilities. These programs run detailed simulations of their ancestors, which happen to be us, giving the simulated characters some sort of artificial consciousness. According to this theory, we may not be the original race of humans, but simply simulated versions created by the advanced descendants of the original human race. This may all sound extremely far-fetched, depending on who you ask, and maybe even ridiculous to some. But when you think about the advancements of the human race in the last 2,000 years, it may not be so improbable after all. If you were to go back in time to explain to an ancient Egyptian about the concepts of AI and quantum computers, they simply would be incapable of comprehending the idea, and you might just be accused of being mentally unstable. Also, taking into account the level and speed of technological advancements we've experienced in the last 200 years alone, it doesn't seem so improbable after all. It took humanity less than 200 years to move from the industrial age to the atomic age, then computers. And in the last 20 years alone, we've almost perfected artificial intelligence. So it's not much of a stretch to imagine what we would be capable of, say, 1,000 years from now. Other philosophers and scientists have expanded on the tenets of simulation theory by giving possible explanations to the beings responsible for our simulated reality. David Chalmers, a professor at New York University, described the higher being responsible for our possible simulated reality as a programmer in the next universe up. Basically, our presumed programmer exists in a plane that we might consider godlike, in some higher dimension or universe that we simply cannot fathom or even access. According to Chalmers, they may just be a teenager hacking a computer and running a simulation, which to us is our entire existence, but to them, it's just a common simulation program. Whatever the case may be, the programmer of a cosmic-level simulation like ours would have to be all-powerful. To us, anyway. So, how would a simulated reality even work, if it was actually possible? Well, for a simulated reality to operate on a cosmic level like our own, one of two scenarios is most likely. The first is, everything that exists is simulated. In this scenario, everything that exists, from every person, object, sensation, environment, and occurrence, is a product code and programming. This particular simulation would involve hardware powerful enough to cause the kind of detailed interaction that exists on a cosmic, intergalactic scale. All of reality, from the human experience down to the minute physics of the universe we observe, would be running on a quantum supercomputer far beyond our current capabilities. In this simulation, breaking out would mean that the person would cease to exist, as their existence is a result of the situation. It would be like deleting a character from a game, only this character wasn't aware its entire existence was a result of computer programming. The second scenario is, the world around us is a simulation. This scenario assumes that although humans are part of the simulation, we are in fact real and organic, but the world around us, and a good number of people as well, are simulated. To achieve this, the main objective of the simulation would be to trick our minds and consciousness into believing that we in fact live in a real material world. A world where all our sensations and experiences feel real and indistinguishable from digital programming. The other simulated human characters are so fine-tuned to the human experience, like highly sophisticated AI, that they are perceived as real by the human mind. In this scenario, the simulation is similar to the kind depicted in the movie The Matrix. The Matrix showcases a post-apocalyptic world where humans are farmed and harvested for their heat and energy, with their minds imprisoned in an artificial reality known as the Matrix. In the movie, humans trapped in the Matrix go about their lives without realizing they are actually living in a simulation. The human consciousness is real, but the world around them is a completely programmed simulation. In this scenario, humans could technically break out of the simulation as our physical form exists somewhere in some dystopian future. How we would break out and what awaits us on the other side is an answer this theory can't provide. we would either have to come to some level of enlightenment or self-awareness to realize we were in a simulation. Or, the most likely possibility would be if someone or something were to alert us to our programmed existence and pull us out. While simulation theory is as far-fetched as it gets, there are some pretty convincing arguments that support it. One of the prevalent arguments is the inevitability of human advancement. Bostrom argued in his paper that if humans were to survive thousands of years into the future, a future which is uncertain with our current disposition for wars and alarming use of the planet's resources. But if we somehow reach a post-human state where we achieve the highest level of our technological advancement and surpass all energy constraints we currently face, then we could have the capabilities to run such cosmic-level simulations. Theoretically, we could have these capabilities if humanity survives long enough to reach a Type 3 or Type 5 civilization on the Kardashev scale. This scale was postulated by Russian astronomer Nikolai Kardashev in 1964, where he broke down the level of advancement a civilization could achieve into 5 types, determined by the amount of energy they can harness and use. A Type 1 or planetary civilization is a species that has successfully absorbed and utilized all the energy available on its host planet and from a neighboring star. This civilization can use this energy to meet the energy demands of a growing population. Currently, humans aren't up to a Type 1 civilization, as we have yet to perfect even fusion energy or global-scale renewable energy. Humanity would have to increase its current energy output by 100,000 times to reach a Type 1 civilization. By then, we would be able to regulate all natural resources and forces on the planet, such as the weather, volcanoes, earthquakes, tsunamis, and much more. A Type 2 or stellar civilization doesn't merely tap solar energy, but can completely harness the energy of its host star. They would achieve this by building a device known as a Dyson sphere. A Dyson sphere is a theoretical star-scale device that would be built around an entire star, harnessing most, if not all, of its energy. This civilization would be a galactic powerhouse and almost impossible to destroy. They would have the technology to easily vaporize any killer asteroids or simply move their home planet out of range. A Type 3 or galactic civilization would be a master race across the galaxy, as they would possess immense galactic knowledge pertaining to energy and technology. If humanity ever reaches a Type 3 civilization, thousands of years of mechanical and biological evolution would result in the humans of this civilization being highly evolved from the humans of today. Cybernetic form may be the norm, with regular humans considered to be subspecies or inferior beings. This civilization would be capable of self-replication through cloning and nanotechnology, able to replicate their population throughout the galaxy in the shortest time. A Type 3 civilization could be capable of a Matrix-level simulation where the human mind is captured and tricked into believing it's living out a full life in a universe. The energy and technology requirements needed to meet this level of neural manipulation would be available, and they could run countless simulations for thousands of years. Being cybernetically advanced, they could be interested in understanding how early humans, their ancestors, lived in a time of mediocre technology and limited energy. A Type 4 civilization would be more powerful, harnessing the energy from entire clusters of galaxies, and eventually its universe, essentially becoming an immortal race. Now, a Type 5 civilization would be truly capable of a cosmic-level simulation. This civilization would be so advanced they could escape their own reality and universe, essentially transversing the multiverse. This civilization would have mastered the secrets of creation to the point they could build or simulate a custom universe. A Type 5 civilization fits into the most extreme possibilities of simulation theory, as the reality they would create wouldn't just be mind-based, but would be made of actual observable matter, much like the universe we inhabit now. If we essentially live in a custom universe created by a Type 5 civilization, it would explain most, if not all, the perfections we observe in the universe. The random alignment of the universe would suddenly make sense, because as it happens, none of it is random, but everything is and was carefully curated by beings who simply did so because they could. Conventional science points that any idea of a creator or creators is purely fictional. The generally accepted belief is that the universe simply came into being through the Big Bang, producing a self-governing and self-sustaining cosmos. The cloning of our existence. This theory is widely supported by most scientists because of the endless possibilities of an infinite universe, widely known as multiverse theory. If we reduce the basic constants and fundamentals of the universe to a game of cosmic lottery, then the possibility of having one perfect universe out of an infinite multiverse becomes more probable. The multiverse theory states that there is an infinite number of universes, each with its own values for the constants of nature. It just happens that our universe had the right mix of energy for stars and planets to form, and for life to be possible on at least one planet, Earth. The multiverse theory assumes that there is a cosmic metric or standard that determines the different outcomes for each universe to exist. For instance, if the equation for the Big Bang that created our universe has a component with the value 10, then there is a universe that exists in the multiverse where its coefficient is 9 or 11 or even 100. The origins of the multiverse also have different theories and possibilities. One theory states that a single Big Bang event resulted in the entire multiverse. In this theory, there are several measurements of heat and density that result from a single Big Bang, all of which eventually play out on different timelines. In this scenario, there is a multiverse with endless versions of you and equal versions of Earth, all playing out with different scenarios. In those universes, you might live in a different country, might have won the lottery, or probably been hit by a bus. Who knows? These parallel universes all exist simultaneously and will most likely end the same way to kickstart the next infinite layer of multiverses. Some scientists believe we might be able to observe these parallel universes, as they might leave imprints as they collide with our own. This spin-off from Penrose's conformal cyclic cosmology isn't one Penrose agrees with, but is still as theoretical and speculative as his original theory. In all, even the multiverse is based on speculative physics, but the major problem is we cannot prove its existence. This is because, regardless of our technological advancement, we may never be able to detect these other universes because they are essentially outside our bubble of space and time. They are beyond what is known as our cosmic horizon. This still brings us back to the very fundamental question: of whether the universe, or universes in this case, arose from nothing or was some higher being responsible for the creation of the universe as we know it. We've stretched the limits of physics and quantum mechanics, none of which can fully explain the origin of the universe with our current knowledge of science. But looking at myth and folklore, Penrose's cyclic model of the universe has a striking resemblance to the Norse mythology of the Ouroboros. The ancient serpent, Jormungandr, is the child of the Norse god Loki, who consumes its tail, and the circle in turn sustains the balance of the world. Or it could simply prove the existence of some divine being at the beginning of all creation, responsible for kickstarting the very first universe, which goes on to repeat the cycle of expansion and creation to the point of creation we are now in. What do you think is behind the curtains of nothingness at the start of creation? Most scientists agree that the universe itself began from a singularity, a single, unimaginably hot and dense point that occupied a space 1 trillion times smaller than an atom. This singularity didn't exist in space. Rather, it caused the explosion and expansion of space-time itself. In simple terms, the singularity that caused the Big Bang came from nothing, but contained everything. The singularity is agreed to have had just the right amount of heat and energy needed to balance the creation of all we see and observe in the universe today. Simply put, if the singularity was a few degrees hotter, colder, or any less dense, none of what we see today would have been possible, including our very own existence. But regardless of how incredibly precise the singularity was, it even further raises the question of what could have created such a perfect combination of energy and heat. Most scientists will support the theory that the singularity resulted from nothing, and before the singularity, there was absolutely nothing. No space, no time. But within a tiny fraction of a second, the singularity came into existence, and seconds later, expanded into the Big Bang. This is regarded as the theory of nothing. While the theory of nothing is widely accepted, it breaks every law of physics and quantum mechanics that governs the observable universe. The basic laws of physics state that nothing can be created from nothing. For something to exist, there must be something or pre-existing components for it to be created. In this case, the singularity that resulted in a Big Bang. For the longest time, scientists have attempted to explain the state of nothingness that preceded the Big Bang. They have attempted to see if there are observable theories that could explain the phenomenon where nothingness could result in the perfect circumstance that created something as magnificent and near perfect as the universe. In an attempt to understand, scientists looked further into the future to one possible end of all existence, what is known as the Big Freeze. With the Big Freeze theory, it is believed that as the universe continues to expand, with stars and galaxies moving so far apart from each other that they can no longer generate enough heat and energy to keep the universe warm, they would slowly cool and fade away. With the last stars fading away, the entire universe will be plunged into an infinitely long and dark era where the only cosmic beings that remain active will be black holes. As the universe continues to expand and freeze, These black holes would consume every last bit of matter left in the universe. It would eventually reach a point where there is no light or matter left in the universe for these black holes to consume, and over what could be trillions of years, they will begin to fade away as well. Space-time will continue to expand outward until there is absolutely no light or matter in the entire cosmos. This model of the end of our universe, where the entire cosmos essentially fades away into nothing, is strikingly similar to the point of nothing which preceded the Big Bang. Some astronomers believe that this future desolate end of our universe could be the perfect recipe that might have produced the singularity that created the Big Bang. In essence, the death of a previous universe could have laid the very dark and empty foundation that created our own. A beginning from nothing. All attempts to answer the processes that result at the beginning of creation have all come to a similar conclusion: that the era of creation must have existed as a result of some pre-existing factor. Some explanations have gone as far as stating that it was a result of supernatural forces or a divine being. But before we jump into the chances of the existence of a god, there are still theories that physics can still explain. Such explanations include the existence of a multiverse, a belief that there is an infinite number of parallel universes. But this still leaves the question of how each universe is created. The most widely debated scenario is the existence of a cyclic model of universes, such that the death of one universe leads to the birth of another, and the infinite cycle continues. This takes us back to the theory of the Big Freeze and the apparent nothingness at the end of our universe being quite similar to the nothingness that precedes the Big Bang. Scientist and Nobel Prize-winning physicist Roger Penrose postulated a plausible but highly controversial model for a cyclic universe, which he termed conformal cyclic cosmology. Penrose was inspired by the intriguing mathematical connection between the very cold and empty state of a frozen dead universe and the incredibly dense and hot state at the beginning of our universe during the Big Bang. This radical theory aims to explain the correlations and similarities between those two states as they appear almost mathematically identical when taken to their limits. However paradoxical it may seem, a complete and total absence of matter, which may be the case at the end of our universe's existence, may have already resulted in all the matter we see around us in our current universe. Penrose's idea is highly debated and rightly criticized in the science community, but let's take into account the fact that so far, conventional science has been unable to explain the processes that led up to the very first nanoseconds of the Big Bang, and has been unable to go back any further. Penrose's idea begins to look more plausible. Conformal cyclic cosmology states that our current universe did not simply emanate from nothing, but was in fact the product of a previous dead universe. In his published paper, Penrose revealed that he had discovered what could be evidence of the existence of a previous universe. This was based on centric circles he discovered while studying multiple versions of the cosmic microwave background, or CMB. He published the data from the discovery stating that an earlier universe might have quite possibly existed with its last fading conditions, leading to the Big Bang that created our own. Penrose stated that the Big Bang was a result of the final stages of this pre-existing universe, which he stated was filled with billions of evaporating black holes that had consumed all cosmic matter within their own universe. He went on to state that the final stages of this pre-existing universe were filled with evaporating black holes, which at the last stages of their existence were nothing but photons that existed outside of space and time. According to his research, these last remaining photons of a pre-existing universe were incredibly similar to the first photons that we discovered during the very first milliseconds of the Big Bang. This essentially means that the singularity that resulted in the Big Bang is mathematically or otherwise equivalent to the cold, expanded, pre-existing universe. The basis of Penrose's theory was based on his study of the cosmic microwave background. This is essential because the CMB is the earliest scientific picture we have of the early stages of the universe after the Big Bang. It shows the most primitive electromagnetic radiation that engulfed the early stages of the universe. The cosmic microwave background can be found all over the universe and currently serves as the most important source of data reference, showcasing the radioactive and thermal state of the early universe. The CMB dates back to when the early universe became cool enough for protons and neutrons to stabilize in order to fuse, forming the very first atoms during a period known as recombination. This period of recombination has been observed to have existed around 380,000 years after the Big Bang. In our study of the Big Bang, we have dealt with fractions of a second, so 380,000 years might seem like a long period of time. But considering the universe is over 13 billion years old, it is still a relatively small interval. The CMB can be observed using a dedicated radio telescope, which would show a faint glow of multiple colors existing in the space between stars and galaxies. This glow is not associated with any other cosmic object in the universe, but is simply a relic frozen in time from the earliest stages after the Big Bang. Penrose's theory has come under heavy criticism, as there is nothing to indicate that a dead, empty universe would have the materials and infinitely dense energy needed to propagate a Big Bang. Penrose's theory of conformal cyclic cosmology offers some answers, albeit speculative, to the origins of our current universe, but it still leaves a big question unanswered. Even if our current universe is part of a long chain of pre-existing universes, how did the entire cycle of universes begin? What gave rise to the very first universe that began the chain of eons and universes? Another theory that tries to explain the perfections we see in the universe is the theory of multiverse. The common thing all these theories and postulations have in common is that none of them can actually be proven using current science. In the end, they are still hopeful scenarios, something we call faith-based science. This concept attempts to draw similarities between science and faith and not see them as being mutually exclusive the way most people think. We live in a world where science, by definition, is a limited discipline and has its limits in explaining why things are the way they are. Science can explain the natural and physical laws of the universe, such as the attraction between two bodies of mass is caused by gravity, or that ice melts at a much lower temperature than mercury or lead. Science can also predict certain laws of the universe, like the trajectory of an asteroid en route to Earth, or the precise day and time an eclipse would happen. However, Science can't tell us why gravity was created in the first place. Science cannot tell us why the speed of light cannot be surpassed by any object in the universe. Yet, quantum entanglement exists, which challenges light-speed communication. Science attempts to explain the how, but even then has its limits. But faith and philosophy go further to give meaning to some of the more mundane yet complex questions that plague our existence. For instance, with simulation theory, it could be possible we're living in a simulated reality, and science would aim to prove this if this is the case or not. But ask yourself, what could be the effects of such findings? If science proves we live in a simulation and tells the whole world, some theorists suggest that it would serve no purpose other than to cause mass chaos and panic. Furthermore, the grand programmers or creators of such a simulation could decide to end our reality, seeing as how our knowledge of their existence no longer fits their design for us. So, what do you think? Is there indeed nothing before the Big Bang? Or is there some God-level creator or race of creators who designed a predetermined universe for us? Or are you more concerned with not worrying about the hypotheticals and instead focusing on the issues we have now? Issues that plague our current existence on this blue planet we call home. Let us know your thoughts in the comments, and we'll see you in the next video. Thanks for watching.